Large language models, they really do feel like magic. But running them, that comes with a very real and honestly a very high price tag. So in this explainer, we're going to pull back the curtain. We're going to show you how to take all that magic and make it faster, smaller, and a whole lot cheaper. Let's dive in. Okay, let me just start with a number that might make you wince. $40. That's about what it can cost to run a top-of-the-line model like GPT-4 for just a single hour through its API. Now, if you're building a real product on top of this, yeah, that cost can get absolutely astronomical really, really fast. But what if I told you that you could take that $40 an hour problem and just slash it by over 95% without really sacrificing performance? I know, it sounds kind of like a fantasy, doesn't it? But it is completely possible. And the secret sauce is optimization. So here's our game plan. First, we'll get into why AI costs so much in the first place. Then, we'll uncover the magic fix of something called quantization, plus a few other powerful tools. We'll see the insane impact this has on cost and speed in the real world, and we'll finish up with a super practical playbook so you can do this yourself. All right, let's tackle the core issue head on, the high cost of AI. We live in this era of just massive models with billions and billions of parameters. And yeah, that size is what gives them all their power. But it's a double-edged sword. It also makes them incredibly slow and expensive. And that's exactly why optimization isn't just some nice-to-have anymore. It is an absolute necessity. The challenge here really breaks down into 4 big headaches. First, these things gobble up huge amounts of super expensive GPU memory. Second, they can be slow to give you an answer. We call that high latency, and that just kills the user experience. Third, every single time you ask it a question, it costs you money. And finally, you want to run one on your phone or laptop? Without optimization, you can pretty much forget about it. So how in the world do we fix this? Well, the single biggest, most impactful technique out there is called quantization. And it's all about a simple idea: doing way more with way less. It sounds super technical, but at its heart, quantization is surprisingly simple. An AI model is basically just a giant collection of numbers, right? We call them weights, and they're what hold all its knowledge. Quantization is just the process of taking those super-duper precise numbers and kind of rounding them to make them simpler and smaller. And this idea of precision is everything. See, models are trained using these highly detailed 32-bit numbers, or FP32, to capture every tiny little detail. But when we just want to use the model, what we call inference, we often don't need all that crazy detail. So we can drop the precision down to 16 or 8 or even 4-bit numbers. And that immediately means a smaller model and much, much faster math. Here's a really easy way to think about it. A full precision model is like a long, flowery paragraph describing a scene with every single little adjective. A quantized model, it's like a short, clear summary. It's way easier to process, but it still gets the main point across perfectly. So what's the actual payoff here? Oh, it's huge. We are talking up to an 8 times speed up in performance. You use way less memory, which lets you run on cheaper, smaller GPUs. This, of course, directly lowers your server bills. And suddenly, putting these models on everyday things like laptops or phones becomes possible. And maybe the best part, if you're careful, you can get all of this with barely any hit to the model's accuracy. Now, quantization is an absolute powerhouse, for sure, but it's not the only tool in the toolbox. Let's look at some other really powerful techniques that you can use to get even more efficient. Yeah, there's a whole suite of these things. You can prune a model by literally snipping away useless bits. You can use knowledge distillation to have a tiny model learn from a giant one. There's a bunch of stuff. Let's just touch on a couple of the big ones. Okay, so let's talk pruning. Think of it like being a ruthless editor for an essay. You go in and you cut out all the redundant words and fluff. Pruning finds all the connections in the model's brain that aren't really doing much and just removes them. You can shrink a model by half this way, often without a big drop in performance. It's pretty amazing. Knowledge distillation, now this one is just really clever. You basically set up a mentor-protege situation. You take a big, powerful teacher model, and you use it to train a much smaller student model. The student literally learns to think like the teacher, and it ends up with all that intelligence but in a much more compact, efficient body. Okay, so that's enough theory. Let's talk about what really matters, the payoff. What does all this actually mean for your wallet and for your app speed in the real world? All right, this is where it gets really exciting. Remember that $40 an hour for a big API? Well, if you host your own open source model like Llama 7B, that cost drops to about $6. But look what happens when you quantize it down to 4 bits. The cost absolutely plummets to just $1.50. I mean, that's just a massive, massive difference. So here's the bottom line. When you combine these optimization techniques, you are looking at a potential cost reduction of 10 to 20 times. This isn't just trimming the budget a little. This fundamentally changes the entire economics of building with AI. It makes it possible for smaller teams and brand new ideas to compete. Okay, I know what you're thinking. This all sounds a little too good to be true. What's the catch, right? Do we lose accuracy when we start squishing these models down? And, the honest answer is yes, there is a trade-off. But here's the thing. It's almost always a manageable one. And the absolute key is to measure everything. You have to benchmark your model's quality on your specific tasks before and after you optimize. That's the only way to know if that huge speed gain is worth what is often a tiny, sometimes even a noticeable, dip in quality. So with all of that in mind, let's get practical. How do you actually do all this? Well, here is your playbook, the actual tools and steps you can take to start optimizing your own models today. And the best news is you don't have to invent any of this from scratch. There's an incredible ecosystem of tools out there. For quantization, you've got libraries like Bits and Bytes that can make it almost a one-line code change. For serving these models at scale, frameworks like VLM are the best in the business. And for running things on your own machine, tools like llama.cpp and Ollama are just fantastic. All right, so let's wrap up with a quick checklist. Your final takeaways. First, benchmark everything. Don't guess. Always start with the easiest method, which is post-training quantization. Use a tool called a profiler to find out where your real slowdowns are. And if you have a really specific job to do, think about distilling that knowledge into a specialized, smaller model. That's where you'll get maximum efficiency. And really, this all brings us to the final big idea. The future of AI, especially in real products, isn't just about who can build the biggest, most powerful model. It's about who can build the most efficient intelligence. It's about taking all that raw power and sculpting it into something that's lean, fast, and truly accessible to everyone.